Hello everyone, today let's look at solving Quantipus number 15, which is a visualization type of brain teaser, and essentially we're given a 9 by 9 by 9 cube, and we're told that it was built out of 1 by 1 by 1 unit cubes, and then it was dipped in paint. So we're asked how many of the smaller cubes remain unpainted. Well, I'm not the best at drawing these cubes, but I tried to draw one here, and basically if we dip this in paint, which cubes are going to be painted? Well, obviously it's just going to be the outside ones, right? All the ones that are on the faces of these sides of the cube. And since my 9 by 9 by 9 cube was originally composed of 1 by 1 by 1 unit cubes, I can essentially just remove all the cubes that are painted on the outside, and then we can just count the number of 1 by 1 by 1 unit cubes that are in the center. So for starters, let's just look at a 2 by 2 by 2 cube because it's a lot easier than a 9 by 9 by 9. And obviously in a 2 by 2 by 2 cube, well, that's just 2 cubed, right? So there's going to be 8 cubes in here. And now think about if we dip this in paint and remove the outer layers, well, how many cubes are going to be in the middle? Now you can probably visualize how there's just no way for there to be a cube in the middle whatsoever, because all these cubes on the outside, well, they're all touching at a single point in the middle, right? If you can imagine it, all of these cubes, even in the back here, they're all meeting at this one point, and there's just no room for there to be a middle cube. If we wanted to actually enclose a 1 by 1 by 1 cube like this, well, we'd have to put one cube here, right? And then we'd have to put another cube here on this face. We basically just have to put one on every single face. So a cube has 6 faces, right? So you can imagine the one back here, the one back here, the one in the front, and the one on the bottom. We'd have to put one on every single one of those, and then we have to make the outside a cube, right? So we'd have to put one here, and we'd have to put, you know, one here. Like you can imagine that we'd need more than a 2 by 2 by 2. In fact, it would be a 3 by 3 by 3, right? Because we need one down here, and you can see how it's going to be 3 tall, and it's going to be 3 wide as well in every direction. Now, if we wanted to enclose this 3 by 3 by 3 cube, well, let's just look at this one line here. Well, we need to put a box here, and then we need to put another one here such that we couldn't see any of the red boxes, right? And we have to put one here and then come down here with boxes too. So you can see that in every direction, I'm adding one box on this side and another one on the bottom, right? Same here, I'd add one here and I'd add one on the other side. So I would need a 5 by 5 by 5 cube to enclose a 3 by 3 by 3 one. So now you can see that to enclose a 1 by 1 by 1, I needed a 3 by 3 by 3. To enclose a 3 by 3 by 3, I needed a 5 by 5 by 5. So obviously, if I have an n by n by n cube, it's going to enclose an n minus 2 by n minus 2 by n minus 2 cube. Now, how does that help us? Well, we had a 9 by 9 by 9 cube. So what cubes would we have been enclosing? Well, we plug it in here, and it would have been a 7 by 7 by 7 cube. And how many cubes are in a 7 by 7 by 7 cube? Well, that's pretty easy. That's just 7 cubed, and that's going to be 343. So the answer to this question, how many of the smaller cubes remain unpainted? Well, those are just the ones that are not on the outside, the ones that are enclosed in the middle, and it was 343.